As the world's population continues to increase, so does the amount of garbage that people produce. On-the-go ways of life require easily disposable products, for example, soda cans or bottles of water. Yet the accumulation of these products has led to increasing amounts of plastics around the world. Plastic is composed of major toxic pollutants, which has the potential to cause great harm to the environment in the form of air, water, and land pollution. For more than 50 years, global production and consumption of plastic have continued to rise. An estimated 299 million tons of plastics were produced in 2013, representing a 4% increase over 2012 and confirming an upward trend over the past years. In 2008, our global plastic consumption worldwide has been estimated at 260 million tons, and according to a 2012 report by global industry analysts, plastic consumption is to reach 297.5 million tons by the end of 2015. The Marine Conservancy has predicted the decomposition rate of several plastic products. It is estimated that a foam plastic cup will take 50 years, a plastic beverage holder will take 400 years, disposable diaper will take 450 years, and fishing line will take 600 years to degrade. How does this become a global problem? The prominence of plastic pollution is correlated with plastics being inexpensive and durable, which gives reason to the amount of plastic utilized by women. However, it is slow to degrade. As a result, over the last 10 years, we have produced more plastics than during the whole of last century. Plastics constitute approximately 90% of all trash floating on the ocean surface, with about 46,000 pieces of plastics per square mile. According to the EPA 2006, 6% of plastics float and it can drift for years before eventually concentrating in the ocean. It takes about 500 to 1,000 years for plastics to degrade, hence causing pollution. Plastics pose a risk to marine life as they degrade very slowly and could also enter the marine food chain. They end up causing entanglement and ingestion hazards to the animals. About 100 million seabirds and 100,000 marine animals are killed annually from plastics in our oceans.
Water is perpetually moving in the ocean in specific patterns called currents. At a global scale, any solid object that is released into the ocean from one country can move through these water currents and end up on the other side of the world. There are specific spots in the ocean where the currents spiral, forming areas called gyres. Keep in mind that all aquatic systems, down to streams and standing pools, can have their own patterns of water currents in areas where objects can accumulate. In this video, we're focusing on the accumulation of plastics in the ocean at a global scale. There is so much plastic accumulating in these spiraling areas of the ocean that we call them plastic garbage patches. The Great Pacific Patch is in the central North Pacific Ocean, so the US is on one side, California, and Japan on the other. We turn to science to ask, to what extent is the plastic affecting the ocean's ecosystems? Scientists have known for many decades about the issue of plastic debris in the oceans. However, there are still a couple of questions that we need to learn more about to really understand the magnitude and effects of the problem. According to Dr. Richard Thompson, a professor of marine science and engineering at England's Plymouth University, at this point there are more questions than answers. Further research is needed to understand the issue at a larger scale. How much plastic is in the ocean? We have one estimate, but we don't know for sure. How do plastics degrade? Where do they go? And what are their effects? What are the impact on the ocean's ecosystems? How much are humans exposed to plastics in the ocean? And what are the effects on humans from exposures to these plastics? There isn't enough knowledge for scientists to conclusively state the impacts of plastic pollution on the ocean's ecosystems as a whole, but there has been research on the impact of plastics on specific components of this issue. Scientists have identified two physical ways how plastics can affect marine life. First, marine life can ingest plastic debris, mistaking the plastic for food. In this photo, an albatross fed plastic to its baby, seen here in the photo. This baby albatross was found more than 3,000 kilometers from the nearest land. The plastic debris can also move up the food chain. Therefore, just because one marine organism accidentally eats the plastic does not mean it's the only organism affected. Secondly, marine life can get entangled or stuck in types of plastic. This turtle was trapped in a piece of plastic of a six-pack when she was young. Although her body was able to grow around the plastic, her organs failed to fully develop. In terms of the effects on humans, science has shown that the very components that make up plastics can be harmful to humans. Plastics can also act as magnets, and in the ocean, plastics can absorb a whole suite of substances that are in the water. Whether the plastic is harmful from its own makeup or from the toxic substances that it absorbs, the potential effects on humans from these plastics is of concern. Even being exposed to really small concentrations of certain compounds can affect our endocrine system, the system that uses hormones to keep our body in check. Since plastics come in all shapes and sizes, different sizes of plastic have different effects on different animals. Right now, scientific research has started to focus on the effects of microplastics, plastics that are less than 5 millimeters in size. Because they are too small to be filtered out in our waste management processes, they are everywhere in the ocean and therefore accessible to all marine organisms. It's important to keep in mind that although there are a lot of unanswered questions, the scientific community and government agencies across the world are working right now to answer these questions.
Great news! There's been recent policy addressing part of the plastics issue for the first time since the 1970s. Microplastics are now listed as a hazardous substance in the Canadian Environmental Protection Act. But what does that mean? In risk assessment, risk is the hazard of a chemical times the likelihood of exposure. In other words, for you to be at risk, the substance has to be harmful, and you have to come into contact with it. Acknowledgement that microplastics are hazardous means that the Canadian Environmental Protection Act can now back actions to reduce exposure, such as banning. This is a step up from the old marine pollution regulations, the 1978 Protocol to the International Convention for the Prevention of Pollution from Ships, MARPOL, which recognized that vessels present a significant and controllable source for pollution into marine environments. Legislation at the national level also plays an important role. Individual countries can be effective through their own regulations, such as laws that require degradability standards to reduce hazard, or that encourage recycling, to encourage containment and reduce exposure. Ports and ocean carriers have to adapt these regulations prohibiting disposal of plastics at sea as well. But the biggest difficulty, however, when it comes to legislation is actually enforcing it in an area as vast as the world's oceans. It is therefore essential that neighboring countries work together in order to ensure that we can actually address this global plastics problem. The policy has been based largely on eliminating pieces of the plastics puzzle, the easy pieces. This is due to industry trending towards increasing the use of plastics, and policymakers not wanting to butt heads directly with industry like that, unless they've got sound science to back them up. Given the nature of this problem, and the growing trends in the use of plastic, in addition to global growing human populations, we need policy to address the hard parts of this problem as well.
It takes a really long time for plastics to break down, even if we continue to spend money finding out the specific numbers of how much plastics is out there.
Or specific pathways of how plastic leaches into the environment. Creating a policy with threshold values of acceptable amounts of plastic to release into the environment is not fixing the problem. It doesn't go away.
Although at the very least, policies with thresholds should in theory reduce the amount of plastic released into the environment. This is a band-aid solution, and it's not addressing the root of the problem. We look to science and technology to address two research questions.
How do we contain and clean up the plastics that are already out there? Reduce exposure.
What alternatives to plastic are there? How do we reduce the hazard?
Plastic pollution is a global problem. Any science or policy that addresses this problem must consider that this product is used and or released by every country, and therefore requires global collaboration.